Consider this question. How is adding a negative integer different from adding a positive integer? Well, first of all, in a number line, when you're adding a positive, you move to the right. If you're adding a negative, you would move to the left. And when you're using counters, the shaded counter represents the negative value, and the unshaded value would be, or unshaded counter would be the positive value. Let's look at some examples and model them. -5 plus 9, if you use a number line, you want to start with the first number, which would be -5. So draw your number line, find -5, and since you're adding a positive 9, you're going to move to the right. So you're going to lengthen that a little bit, and you're going to move to the right 9 places, 9 units. Now, of course, 9 units would take you past 0. 5 units takes you to 0, and 4 more makes a total of 9, which gives you a positive 4 for the final answer. Using counters, you would use 5 shaded. Let me draw 5 shaded here. 5 shaded counters is -5. Then you would draw 9 more counters, but leave them unshaded. And then what you do is you look for 0 pairs. Circle each of those, and 0 pairs would cancel each other out. So we would have 4 unshaded counters remaining for a positive 4 answer. Our next problem starts with a positive 5, and you're adding a -9 to it. So on the number line, we'll start with the first number, 5. Mark it to the right, and we're adding a -9, so we're going to move 9 to the left. So extend that line, then move your arrow to the left 9 places. Now 5 to the left, of course, would take you to 0. And then there would be 4 more to make a total of 9 to the left, and takes you to -4 this time. And now with the colored counters, you would have 5 unshaded for the positive 5, and 9 shaded for the -9. Give me a second here to shade these in. Of course, after we shade these in, we're looking for 0 pairs, and there will be 5 different 0 pairs, all canceling each other out, leaving us with 4 shaded counters, which would be a -4 answer. Number lines can be used, and counters can be used with larger problems, larger number problems. So for -52 plus 12, you would start the -52 because it's the first number. That's pretty far to the left. And you're adding a positive 12. So you'd move to the right, have your arrow showing to the right, 12 places. Then you have to stop and think, well, how far to the right is that from -52? Well, 2 to the right would take you to -50. And then you need 10 more, which takes you to -40. So that'll be a -40 answer. So in order to use counters with a larger number like this, a larger value, instead of writing 52 circles and shade them, we're going to do 5, and each of those have 10. They count as 10s. And then you need 2 more, which represents the ones, so it'll be 52. And if you shade them, that would be the -52. Just keep in mind, 5 of those are worth 10 each. And then for the 12, you need 1 10, leave it unshaded, and 2 1s. Now look for 0 pairs. Those 2 1s are 0 pairs, and the 10 and the -10 are 0 pairs. So you're left with 4 shaded 10s, which would be -40 for the final answer. Now let's consider adding integers with different signs without using a model. How would we do that? Well, here are a couple examples. -25 plus 5, a negative plus a positive. What we're going to do is we're going to take the absolute value of each one, 25 and a 5. We're going to subtract them. There's actually 20 more negatives than there are positives, and you use the sign of the greater absolute value. So the final answer is -20. So in the next problem, 25 is a positive, 5 is a negative, so you take their absolute values, same as before, subtract, get 20. But since the positive absolute value is greater, you're going to end up with a positive 20 for your final answer. For our next example, we have absolute values of 198. So subtract them, you get 2. And since the 100 has a greater absolute value, you're going to leave it as a positive 2. In our fourth to last example, the negative 98 has an absolute value of 98, and we have a 37 absolute value. Subtract those, you get 61. And since the negative 98 has a greater absolute value, there would be more negatives left, so you'd be a negative 61 final answer. So how can we add integers with different signs without modeling? We actually want to subtract their absolute values, and the answer will have the same sign as the number with the greater absolute value. Sometimes it'll be positive, sometimes negative. Now let's take a look at what happens when we add opposites. We have a positive and negative. The absolute values are the same. When you subtract them, you get 0. So the answer will always be 0.